This is a video about using function notation. We're going to start by looking at a little scenario when Kristen charges $10 an hour to babysit. So we're going to think of the number of hours that she babysits as X and the amount of money she earns for doing that babysitting as Y. And we're going to make a table to represent their relationship. So if Kirsten babysits for 1 hour, then she makes $10. And for 2 hours, she makes $20. And for 3 hours, then she makes $30. And for 4 hours, she makes $40. So we know that this relationship is definitely a function because for every X value, there is only one Y value. Not 2 hours does not allow Kirsten to make both $20 and $30. It only allows her to make $20. So this is a function. And this happens to be a function that we could actually write an equation to represent the relationship between X and Y. Because it turns out that every time we want to know how much Kirsten earns, we can say that Y equals 10 times X, because you take the number of hours, multiply it by $10, and you find out how much she makes. So this is the equation for this function. And the equations for functions can either be written the way that I have them, y equals 10x, or we could say, instead of y, we could say f of x equals 10x. So it's f parentheses x, and f of x, in parentheses like this, you say f of x. So what that's basically saying is the value of the function when x is a certain thing. So just like y is the value when you put in an x, f of x is the value when you put in a certain x. So to understand this a little bit more, I want to take a look at what happens at a chicken nugget factory. At your typical chicken nugget factory, you've got your chickens and they're waiting in line to go into this machine that we're going to call the nuggetizer that's going to turn them into chicken nuggets. So the chickens are the input for the nuggetizer. So they go into this machine, and when they come out, they have magically turned into chicken nuggets. We would call the chicken nuggets the output of the nuggetizer. Chickens go in, chicken nuggets come out. In the same way, in a function, x is what goes in, and f of x is what comes out. So we put in x, and f of x tells you what happens in the function when you put it in. So x is the input, like the chicken, f of x is the output, like the chicken nugget. So let's say we take a trip from the chicken nugget factory to another factory that evaluates functions. So in this factory, our input are x values, and our output are f of x's. And instead of a nuggetizer, we have a function machine. In this machine, f of x equals 10x. So what happens is that when we put something into the machine, so instead of chickens, now I have a 2, it's going to take that 2 and multiply it by 10 to give me f of 2. So when I put this 2 through the machine, all of a sudden my 20 comes out. So the way that I got 20 was I put in 2 for x, and so f of 2 told me anywhere in the function that I saw an x, instead I'm going to put a 2, and then 10 times 2 equals 20. So what you want to know is that f of 2 is the value of the function when x specifically is 2. So when I say the value of the function, that's like the output. That's like the chicken nuggets. Whereas when x is 2, that's what we put in. So we had to put that in to get a value. So now we'll look at some examples. We're going to evaluate this function. So if f of x equals 10x, so that's what we were using, I want to find f of 6 and f of 11. So first I'm going to find, so this is two separate problems. So first I'm going to find f of 6. So we're starting out with, we know that f of x equals 10x. But what we want to do is do f of 6. So for f of 6, we're going to put 6 wherever we see an x, so that we can say that f of 6 equals 60, because we did 10 times 6 equals 60. So what I did here is when I see x, I replace it with 6. Now we'll do f of 11. So f of 11 is a separate problem, so we're finding two different values. For f of 11, what we're going to do is wherever I see x in the function, I'm going to put in 11. So I'm going to do 10 times 11. So I'm going to know that f of 11 is 110. So we have our two answers. Now we'll look at ones that have different variables. So in my next function, my function is g of t equals 2.3t plus 10. So I changed it from x and f of x to t and g of t. It's just different names, nothing different. In this one, the t is my input, so I changed it from x to t. And what I get out is g of t. So when I do the function g on it, that's what I get out. So g of t is my output. So the question says, find g of t when t equals 2. So g of t equals 2.3t plus 10. So if I'm finding g of 2, so when t equals 2, I need to find out what g of t is. So that's like saying, that basically means find g of 2. So g of 2 is going to be 2.3, and then where I see a t, I put in a 2, plus 10. So that means that 2.3 times 2 is 4.6, plus 10 equals 14.6. So g of 2 equals 14.6. And then my last one, it's the same thing. I have h of x equals a half x minus 3. It's the same thing. X is my input. That's what's going in. And what I'm getting out is h of x. So in this question, they ask me to find h of negative 8. So they want me to put in negative 8 and find out what I get out. So h of negative 8 is going to be a half times negative 8 minus 3. So if we multiply, I'll put negative 8 over 1. That's negative 8 over 2. If I multiply a half times negative 8, which gives me negative 4. That's all minus 3. So negative 4 minus 3 is negative 7, which gives me my answer. Now that you've seen this happen a few times, it's time for you to try 2 on your own. So here are two new functions. F of x is a fourth x plus 1, and I want you to find x, f of 24. So remember, x is your input, and f of whatever x you're putting in is your output. And in number 2, we have h of c. So c is what you put in, and h of c, whatever your c happens to be, h of c is your output. And so in this one, I'm saying, please find h of c when c is negative 3. So that's what you're putting in. You're putting in negative 3 in this one, and you're putting in 24 in this one. Please add these to the end of your notes, and we'll discuss them during our next class. Good luck.